This conference will now be recorded.
Okay, so good morning team. In this Databricks Data Engineer Master Program, so in today's session we will talk about how Spark determines and adjusts partitions with the repartition versus Coalesce. Okay, so let's understand how Spark determines and adjusts partitions, and let's understand the difference between repartition versus Coalesce. What is meant by determines? Determines means how we can able to find, how we will know the number of partitions. Adjust partitions means how we can increase or how we can decrease the partitions as per our need. Then what is this repartition and what is this Coalesce transformations, we will be understanding in today's session. So we will learn importance of adopting the best partition strategy, Spark configurations, repartition versus Coalesce transformations. Repartition is basically used to increase the partitions, and you can also use repartition to decrease the partitions. If repartition is able to increase, if repartition is able to decrease the partitions, why do we need Coalesce? Okay, so we will discuss the difference between these two, but Coalesce we can use only to decrease the partitions. If you want to increase the partitions, you have only one way is repartition. But whenever you want to decrease the number of partitions, there are two ways. One is repartition, second one is Coalesce. Okay, what is the difference between these two? We will discuss. Very important interview question, plus very important for all of you to understand what is the difference between these two. Conclude difference between Coalesce versus repartition. Yes. So let's talk about importance of adopting the best partition strategy. Why we need to maintain proper number of partitions. Let's understand. Okay, Spark is known for its speed due to its dependence on parallel processing. Correct, right? So we already discussed as part of the Spark architecture. You have a computer with the multiple cores. If you have a multiple cores in a computer, each core can able to process a one partition. Now let's imagine you have two computers. Each computer is having a four cores. Now total how many number of partitions I can able to process at a time?
8 cores.
8 partitions I
Eight
can able
partitions.
to process at a time. Now here whatever partitions we have, those partitions are key to parallel processing, isn't it? When you have a 8 cores, minimum you need to maintain 8 partitions, or you can also maintain 16 partitions. You can also maintain 24 partitions. When you have 8 cores, multiples of 8, you can maintain the number of partitions. Multiple of 8 means 8, 16, 24, right? For yeah, 24. Next, 32, 40, 48, 56, and so on. You can maintain the number of partitions in the multiples of 8. Now, what will happen if I am not maintaining the multiples of 8? For example, I have 8 cores, but I have only 4 partitions. What will happen in this case, team? We already discussed this example. Anybody remember? Please tell me.
There will be a lot of unutilized thing which is not effective. Its cost will be more.
Very good. It is kind of, let's say you have a computers, two computers we have. and each computer can able to process 4 partitions at a time. But what you have done, you have only 4 partitions. If you have a 4 partitions, you are using only this computer and you are not using this computer. That is not a good practice, isn't it? You need to make sure all the resources are good, all the resources are used. Now, if you have 8, well and good, all the 8 like all the 8 cores will get a task. All these things are going to run at a time. Now, let's imagine we have 12. If you have a 12, what happens, Tim? First, it will submit all the things are first 1 minute, all the tasks running parallelly. So once within 1 minute, all 8 are succeeded, next 1 minute, only you have a, because if you divide this into 8 and 4, first minute 8 will run, next minute only 4, meaning in the second minute you are using only this computer, only one computer again, and you are not using the second computer again. This is not good, isn't it? That's why instead of 6 12, I'll make it as a 16, so that first minute 8, second minute also 8 will come. Let's say if we have 22, what will happen to him? First 8, next 8, next 6 will go. Correct? So what happens? First minute, all these things will run parallel. Second minute, all the things will run parallel. Third minute, these 4 will get a task and these 2 will get a task, but these 2 cores are idle. You are not using them again properly, isn't it? So that's why the partitions are key to parallel processing, and you need to maintain this number of partitions properly. Proper design of partitions can automatically enhance the performance. We just have seen the example. If we have, if you are utilizing all the partitions, all the cores properly, your time will automatically reduce, because instead of creating partitions, each partition is having 1 lakh. If you create 8 partitions, now it will get each partition will get only 50,000 records. So instead of processing 1 lakh, processing 50 lakhs will be faster, and all the 8 are running parallel here. Because if you take a 4, only 4 cores are using, 4 cores are ID. That's why I divided these 4 partitions. Each partition is 1 lakh to 8 partitions. Each partition is 50,000. Now what happens? All the things are running parallel. Now at least half of the time you can save. Here 1 lakh records we have per partition. Now 50,000 only. Understood? Clear? Now, dividing data into manageable chunks allows Spark to distribute tasks. Okay, so dividing your huge files data into manageable chunks, small chunks, it allows Spark to distribute tasks across, distribute tasks, or you can say distribute these partitions across multiple cores of a concurrent processing. Concurrent processing means parallel processing. At that time, all the partitions are going to run. Key considerations. Two things. As of now, we talked only about right number of partitions. Okay. Now let's talk about right sized partitions. Okay. What is right sized partition? Is, let's imagine you have two computers again. Okay. Let's imagine you have each computer is having a two cores, only two cores. Let's imagine. Now you have 4 partitions, well and good. All the things will get a task. Now all the things are going to run in parallel. Now within these 4 partitions, first partition is having a 10 lakhs records. Second partition is having a 5 lakhs records. Third partition is having 3 lakhs records. Fourth partition is having 1 lakh records. Now let's imagine you have to process 1 lakh records, it takes 1 minute. To process 10 lakhs records, how much time it will take? 10 minutes. 10 minutes. Here, 5 minutes, 3 minutes, 1 minute. Now you submit this here, you submit this here, you submit this here, you submit this here. Now tell me, when, what time this particular core will be freed? After 1 minute. when it will be freed after 3 minutes, when it will be freed after 5 minutes, when it will be freed after 10 minutes. Overall job, how much time it will take to complete? Overall job, how much time it will take?
10 minutes.
10
minutes.
minutes. Okay. Now let's say total how much you have here. Looks like a 19 lakhs records here. If you divide them properly, let's say here also 2 lakhs. Okay, you can consider it as here also 2 lakhs. Now it is approximately 20 lakhs. Now instead of dividing like this data, if I divide here 5 lakhs, 5 lakhs, 5 lakhs, 5 lakhs, now tell me how much time job will take now?
5 minutes.
5
Minutes.
minutes.
So now again, you are able to reduce the time from 10 minutes to 5 minutes. When you distribute the data properly, the size of the partition is equal, then the the performance of job is going to improve again. So two things we have seen. One is you need a right sizing of the partition plus right number of partitions. Both are important in order to improve the performance. What are the two things we need, Tim? Right size of the partition and the right number of partitions we need. Everybody tell me what are the two key things?
Right size of the partition.
Right
Right
number
size
of
of
Right
the
number.
partition. Right number of partition. Everybody please tell me, Tim.
Right number of partitions and right.
Partitions.
Correct. So right sized partitions. Data should be divided into partitions of an appropriate size. Unevenly sized partitions can lead to inefficient resource utilization. Same example I have given, right? If you divide 10 lakhs, 1 lakh job will finish quickly. 10 lakhs job will take more time. Where some cores work much faster than others. Consider a scenario with two partitions, one containing 500 MB, the other containing 100 MB. The smaller partition will finish processing quickly, leaving cores idle while a large partition is processed. Correct? So that is clearly you understand. Right number of partitions. Choose the number of partitions equal to or multiples of the available cores. 32 partitions for 32 cores. This ensures that all the cores are utilized effectively, avoiding idle cores. With 16 cores, 2 executors, total 32 32 cores. Okay, but only 20 partitions, only 20 cores will pick up the partitions, leaving 12 cores idle. You understood this example? If you have a two computers, each computer is having a 16 cores, then total it will become a 32 cores. If you have only 20 partitions, then you are only utilizing 20 cores, remaining 12 cores you are leaving idle. That is what the example it is saying. Clear? Same thing we discussed now. Let's quickly understand importance of adopting the best partition strategy. Designing for optimal performance. Adopting the best partition strategy is essential for achieving optimal performance in Spark application. Yes, the right number of partitions created based on the number of available cores significantly boosts the performance. Meaning, if you have a 10 cores, create a 10 partitions. If you have a 20 cores, create a 20 partitions. It is saying again, if number of partition is not appropriate, it can negatively impact the performance. Same thing we discussed. Now let's say if you have a executors, as we discussed, Databricks is a one-to-one relationship, meaning one computer, only one executor will be there. In each executor, you can provide all the cores that are available. Now total 8 cores we have in this two computers, so you can submit 8 partitions. Spark configurations. So sc.default parallelism, if you see, so sc.default parallelism is a configuration which is going to show you the default number of partitions used for RDD. When no partition number is specified, it usually equals to the number of cores on your mission. In your computer, how many cores are there, those many partitions it can able to create if you have not mentioned the default parallelism or the total number of cores in the cluster. Yeah, total number of cores in the cluster means, let's say if you have taken 2 missions in the cluster, each mission is having 4 cores, then total number of cores is going to be 8. Understood, Tim? So I'll show you this, what is the default parallelism. Next, spark.sql.files.max partition bytes. So when reading data from external tables, these parameters dictate the maximum number of bytes packed into a single partition, meaning what should be the single partition size that we can able to fix it by using this particular configuration. That also I'll show you what is the current default size of the partition which is kept here. We can look at this configuration. These two are important. Sc.default parallelism, that is basically mainly into the RDD. Here we are using Spark session, spark.sql.files.max partition bytes. Okay, next. Repartition. Data frame dot repartition or RDD dot repartition you can able to apply, which is used to increase or decrease partitions in an RDD or data frame. Key points if you try to understand. Repartition is a wide transformation. It involves shuffling.
I think you're on mute, Malaya.
Yeah, I think we lost you. You're on mute.
Yeah, we can't hear his voice.
Yes.
They're showing muted.
No, he's disconnected. He's not in the call.
Hello. Hello.
Yeah, you can hear. Yeah, you can hear.
Yeah, okay, fine. So where audio was not, from where audio issue was there?
White transformation.
Net transformation.
Fine. So wider transformation, right? It involves the shuffling of the data, which is not good for the performance because it moves lot of data from one core to another core through like one a computer to the another computer, one core to the another core. There is a lot of data movements are going to happen through the network, which is not good for the performance. And wide transformation creates a new stage. So repartition is, it creates evenly sized partitions, but evenly sized partition means if you have 100 records, if you divide into 4 partitions, it makes sure 25, 25, 25, 25 is divided. It will not divide like one partition 50 records, second partition 30 records, next to two partition 10 records. No, it will not do that. Okay. Resource consumption, due to data shuffling, it consumes more resources. Okay, as it is uses more resources, definitely it is not good for performance. Default behavior, if parameters are not specified, it uses the default number of partitions. For example, if you say df.repartitions, whatever default number is there, that it will take care. Recommendation, avoid using this function for performance optimization unless necessary. Repartition transformation, avoid applying repartition until unless you really need it. Okay, what is the real use case, when to go for repartition, when we should not go for, I'll explain to you in detail. Just a minute. Okay, this is just theory we are trying to understand for now. Coalesce is used only to decrease the number of partitions. It combines a few partitions and avoids a full shuffle. So there will be data shuffling will be there even in Coalesce, but it will not move all the data. Whatever data is really required, only that data it is going to move. It basically improves the performance compared to the repartition. So less movement of data, uneven partition sizes, performance advantage. So uneven partition sizes are possible in the Coalesce, but performance wise it is good because it is going to reduce the data movement. Okay, so you understood high level. Now in order to understand very clearly, let's consider as a you have a two computers. Each computer is having 3 cores. Total how many cores we have?
Total 6.
6 cores.
How many partitions I submitted now? I
6.
submitted the 6
6 part.
partitions. Now if I apply rdd.repartition of 8 or data frame dot repartition of 8, am I increasing partitions? Am I decreasing the partitions?
Increasing.
Increasing.
Increasing. I'm increasing. So how it will be done is first it will collect everything. Okay, it collects everything, all the data from all the partitions it will collect, and then it will just shuffles all the data. It will keep all the data. Then from that shuffling, once it combines all these partitions from that particular data, it takes 4 partitions. It creates again 4 partitions here. This is how it will increase. Are you getting? So P1, P2, P3, P4, P5, P6. When you combine all these things, what is going to happen? When you combine all these things, what is going to happen? After combining, it is going to divide the data. Okay, from 6 partitions, here 4, here 4. Total 8 partitions are created. Understood? This is how the repartition is going to increase the partitions. Clear tip? It combines all the data, it brings all the data from all partitions, and then again it divides. So that's why there is a data shuffling. Now let's consider it as a again I am using a repartition of 4. Am I decreasing partitions? Am I increasing the partitions?
Decreasing.
Decreasing. This time also same. It combines all the data. It just create 2 partitions here. It creates a 2 partitions here. After combining all the data, some data is coming to P1, P2, some data is coming to P3, P4. Which data? It merge everything. We don't know. Understood? This is a repartition is used to increase or decrease. Now, if you take a Coalesce to decrease the partitions, how Coalesce does is, you see now I am like a rdd.coalesce4 or df.coalesce4. Coalesce I am using here to decrease the partitions or increase the partitions. Am I
Decrease. Decrease.
Decreasing the part.
decreasing?
Decrease.
When you decrease, how it will work, you see. So first computer data will be there in the first computer only, and P1 will be there as it is. As P3 is extra, that P3 will be added to P2 to create a P2 partition. Now here also, here P5 whatever is there, right? This P5 is keeping as it is, and P4 plus P6 it is just combined and created a P4. Understood? Now this is how the Coalesce is going to reduce the partitions. So lot of data movement is reduced, isn't it? So P1 as it is there, P5 is as it is here, it is there. These two combined created one. These two combined created one. That's it. Understood? How Coalesce is basically reducing the data movement in. Okay, clear? So if you look at the difference, repartition. Increase or decrease the number of partitions. Coalesce primarily used to decrease the number of partitions. Use case used when you need to shuffle data for better distribution or performance. You can go for repartition. Coalesce used when reducing partitions. It is ideally without a shuffle. So mostly we go for the Coalesce only. Shuffling always involves a full shuffle of data. So whereas Coalesce it avoid full shuffling, it do the very minimal shuffling. Okay, performance impact more expensive due to full shuffle. It is more efficient when reducing the partitions as there is a very minimal shuffling of the data. When to go for repartitions? So when you need to increase the partitions for parallelism, if you want to increase, you don't have any other way, you need to go for repartition. For evenly distributed data, what is evenly distributed data? I'll explain to you in detail. So repartition, we can go for repartition when you want even distribution. Coalesce. When reducing partitions, Coalesce is recommended. It avoids full shuffling for adjustment of partitions. Shuffle cost is high, lower. Coalesce is lower. RDD syntax is RDD dot repartition, RDD dot Coalesce. Data from syntax is df dot repartition, df dot Coalesce. That's it. Okay. Now, yeah. So hands-on. But before I move on to the hands-on, so let me explain to you very quickly. Focus on this. Okay. Let's imagine you have a total four partitions. Okay. These are the four partitions. Or let's say six partitions we have. Let's imagine we have a six partitions as we discussed. Now let's imagine already you have your 1 to 10 numbers records. Here 11 to 20 records you have, 21 to 30, 31 to 40, 41 to 50, 51 to 60. Okay, team? Clear all of you? Now when you have a data like this, team, okay, when you have a data like this, when I use Coalesce, see repartition we can able to use for increasing, there is no other option. But when you are decreasing, now let's look at two options. What are the two options? When I use repartition, what will happen? When you have used Coalesce, what will happen? Okay, very careful observe. Okay, now you see I'm reducing it to four partitions. What happens in the repartitions? Four partitions will create like this. But the thing is, repartition can have one to one to one, two, three, maybe 11, 15, 11, 12, 13, 14. Okay. Again, you can have maybe we cannot say that again. 1 comma 2 can be there. 11, 12 will be there. 21, 22. Again 31, 32, 41, 42, 51, 52. Like this, data can come here. Okay. So here again 3, 4, uh, 13, 14, 23, 24, 33, 34, 43, 44, 40, 53, 54. Okay. So similarly, so the data can come to here also. Now the question that you need to understand is data is coming from all the computers, all these partitions. Data is joining here, isn't it? Similarly, from all these partitions, data is coming here. Correct, team? There is a lot of data movement is happening or not? There is a lot of data movement is happening or not?
Yes.
Yes.
Please respond, because if you don't respond, I'll feel why I started unnecessary, because you people won't ask, you don't know. But why I have to discuss in depth, I will feel that. Don't make me that kind of a feeling. Please respond, okay? If you put why I'm explaining all these things, you don't even know. You like a lot of trainers will be there, a lot of people will give training, so they can also simply say repartition this, you can remember these points. But I'm not saying that. I'm trying to make you understand in depth what is happening in the background. Please respond to me. So if you see here, there is a lot of data movement that is happening because the data is coming from all these partitions. Now, let's imagine if you come to here, Coalesce. How Coalesce will work, team? You know, right? Data is not going to move much. How it is possible? Because first partition, let's imagine as it is, it is there. Second partition as it is, it is there. Let's say third partition as it is there. Fourth partition as it is, it is there. Now you have only, so meaning already you have here 1 to 10 records. In this you have 11 to 20. In this you have 21 to 30. In this we have 31 to 40. Correct? Now these two partitions are extra. So what it does, it just add here 41 to 50. Here it will add maybe 51 to 60. That's it. But what is the problem that you observed here?
Uneven data distribution.
Uneven data distribution happened. Okay, uneven data distribution. The reason is, so there is a, here 20 records are there. 20 records you have here. Here only 10 are there. Meaning here 20 is there, but here 10 is there. But in these cases it is not like that. Out of all the 60 records, it can evenly distribute to 15, 15, 15, 15. Like this it can able to divide. Understood, Tim? Maybe I have not added all the things properly, but definitely it can have a 15 records here, 15 records here, because some, I think here from here 2 records, from here 3 records, again 2 records, 3 records, 2 records, 3 records, like that. So from all these partitions, data is going to come and form the partition. So even distribution is possible in the repartition, whereas Coalesce repartition is not possible. Okay, we have seen one thing. If the data is already evenly distributed, if you use a Coalesce, what happens, Tim? Coalesce, if you use, it can reduce the data movement, but uneven distribution is possible here. But in the repartition, data shuffling is going to happen, but even distribution is possible. So you need to decide the call. Okay, so if you want performance, you can definitely suggest it to go for the Coalesce team. Okay, you can suggest it to go for the Coalesce only in this case also, because both are having a same problem. So that's why in this case also Coalesce is recommended to go. Okay, next, let's imagine already here you have 100 to 110 also. Okay, now here you have 32, not 30, 110, 111 to 120 records. Now what happens? All the data is going to merge here, even distribution will come. But when it comes to the Coalesce also, if already uneven distribution, what happens? This will be there as it is, this will be there as it is, but this will be there as it is, this will be there as it is, this will be added to this records. Understood, Tim? Are you getting? Now what happens? This partition, this partition will merge with this. Now what happens? This is 1, 2, these two forms 1, 3, these two forms 1, 4. So that's how you need to decide. When you have already uneven distribution, you can even go with the Coalesce. But when you have already even distribution, so in such case also Coalesce is only recommended. Only Coalesce case recommended. But there is a biggest problem with the Coalesce case. In case if you have already uneven distribution, what if it is added like this, which creates a much more problem, isn't it? Because even we don't know how it can able to add which all partitions it can able to combine into one partition, we don't know. So that's why here very carefully observe, whenever you have even distribution, what I recommended him, when you have 1 to 10, 11 to 20, 21 to 30. So when you have all 10, 10, 10 records in 6 partitions, what I recommended to reduce the partitions, Repartition or Coalesce, what I recommended.
Repart-
Okay?
Sorry.
I recommended Coalesce team because we are having a same problems. The problem is, even though when you have even distribution, here uneven distribution is coming, but data shuffling is reducing. But here even distribution is coming, but there is a lot of data movement. Data movement is not good. So that's why we are going with the Coalesce. But let's imagine now the source itself uneven. Okay, because here 20, 20, 10, 10, 10 records are there. In that case, which one you will recommend him? Careful observe. Let's consider Coalesce can add these records to this. Now tell me, will you go for Coalesce or will you go for repartition? Okay, in
If
that case, you need to go for the repartition team. The reason is you just consider if you add this to here, if you add this to here, here you have a 60 records, here you have a 60 records, but you have a 10 records. When you consider it as a just a 10 records, you will not feel that much. Just consider it as a 10 million records, 10 million records, 60 million records, and 60 million records. There is a huge difference, isn't it? So if this kind of uneven distribution is going to be formed in the output, so this will create a biggest problem. That's why we need to compromise with the data shuffling. That's where repartition is recommended. So that's why the summary is, whoever understood or not understood, Coalesce is recommended when your source is evenly distributed. Repartition is recommended when your source is unevenly distributed. So what happens when you have uneven distribution? So this will be, you need to understand what happens is, now anyhow it is going to merge all this data, right? One second. It is going to combine all this data. So let's say you have total 80 records. Now it divides into 20, 20, 20, 20, because it is going to just combines all this data, right? Before it is going to be reducing into 4. But in the Coalesce, it is not like that. Coalesce will keep first 4 partitions as it is, and whatever extra is there, that can add it to the existing partition. This will create a problem, Coalesce. That's why repartition is recommended when your source is unevenly distributed. Coalesce is recommended when your source is evenly distributed. Okay. So that's all things I want to explain to you theoretically. Please let me know if you have any questions. Look at this and let me know if you have any questions, Tim.
Malaya, one doubt. How do we
Mhm.
know the source is evenly distributed and unevenly distributed? Is there any?
Yeah. So how we will know the source is evenly distributed, unevenly distributed is generally when you submit a jobs, your jobs are taking longer time. When your jobs are taking too much time, you remember we can go and see the events, how much time it is deserializing, how much time it is computing. We can look at the each partition size. Do you remember? From
Yes.
Spark UI, I have shown you how to look at the size of each partition, minimum partition size, maximum partition size, and we can see how long it is taking. Whenever you get such issues, when you go back end, you will come to know that there is a issue with the data. Data is not coming properly. So in such cases, you are going to take that particular decision. Okay, data is having a uneven distribution, so we need to take the some action to make it as a evenly distributed data or proper number of partitions. So that's why I told you at the very beginning of today's session, there are two important things: is size of the partition and the number of partitions. Both are important. Now, the number of partitions that can be increased or decreased based on the number cluster available cores. But when you are increasing or decreasing, how you can maintain the size? That's where repartition coming into the picture to make the size of the partition even. when your source already in the event distribution, then you can simply go for the Coalesce to reduce the number of partitions to make sure that you are doing a less shuffling. Repartition, you can go when your source is already uneven distribution. What you need to do, you need to combine everything, then distribute to the minimum number of partitions that you have taken. Clear? You can please focus on this diagram so that you can able to understand. Any questions, please let me know.
I have one
Malaya.
question. Let's say we are using two computes of four cores each, and we have six partitions here.
Hmm.
So that means our transformations would be in a way that we create more partitions.
Yes, because if you have six partitions, you have eight cores, meaning you have eight people to do the work. In your project, you have eight team member, like eight developers, but you have only six use cases to work. Two developers are idle. If you're not using them, if you are paying a salary, no use, right? That is the example.
And in case of less cores and more partitions, that is when we decrease the partitions. Is the vice
No,
versa, right?
you no need to decrease the partitions. Okay, when you when you need to go for decreasing the partition size is very minimal size. Let's say if we if we have uh, let's say 100 MB file, for 100 MB file, if it is creating a 100 partitions, each partition size is 1 MB, so that is not good practice. The reason is, what happens if you have more partitions? The problem with that is, let me tell you here, please focus on this. If you have a 10 people here, okay, let's say 5 people, you have 50 partitions, 5 cores, you have 50 partitions here. Now if you have a very small partitions, the problem with the small partitions is everything you need to submit, resources should be allocated, then deserialization of the data, okay, then it has to be executed, generate the output. Once this output is given, again next 5 should be scheduled, so resource should be assigned and execute, and so on happens. Because the resource allocation, scheduling these unnecessary stuff will take more time if you have a unnecessarily, if you create a more partitions. But if you have a right sized of the partitions, instead of having each file size is 1 MB, let's say at least I want a 10 MB file. Okay, at least I want to have a 10 MB file, then you can divide them into the 5 files, you can submit at a time. Or let's say if you have a 10 files, you can submit within the 2 times. Are you getting? When you have
Yes,
very
Mike.
small partitions, sometimes we want to reduce it. But it no need to be, if you have 5 cores, I want to reduce into the 5 partitions. No, you can put it as a 5 or 10, but you should not have very so many partitions unnecessary, very small partitions. Some partition can be even empty, which cannot have data. So that kind of partitions also will create. That is what we should not keep it. Because simply if you have, let's say, if you have 10 records, you are creating a 16 partitions, what happens? 10 partitions may get a data, remaining 6 are idle partitions, right? So that's why that kind of things to avoid, we will be reducing it. Any
Okay.
other?
Uh, Malaya,
Tell me.
I don't know whether this question is a contradictory question. Okay. Consider that like now while setting up the cluster itself, I made the setup as auto scale. Okay.
Hmm.
But though I'm trying to use the coalesce and repartition in my execution.
Hmm.
So in that case, what will have the impact, or how is the execution will be?
Yeah. So in that case, what is going to happen? Because when you submit your Spark code, immediately cluster will not be sized. Cluster will not add the more computes. First, it will start executing. So if you remember, when we are executing the job, it was showing, right, 4 by 16. Just a minute. Okay. So if you remember, team, we were doing right 4 by 16, 8 by 24. What is that? It is showing out of 24 partitions, I started running 8 partitions. That is what the job was telling. So similarly, Spark knows that, hey, how many more partitions are left? Okay. So 200 partitions left, but we are running only 4. It will check. Oh, it takes a lot of time, seems to be, because there are a lot of partitions still available. Let me go and see the cluster configurations. Cluster, is it allowed to increase the compute? Yes. Then it can increase to the max size. Okay, after increasing the max size, the computes are increased to 16. Now 16 will be launched at a time. Understood? What is the confusion you have? Are you clear, or can you quickly?
No, got it. Because so the maximum utilization will be enabled when this auto scaling is on, and it depends on the execution.
Yes, based on amount of data. When it is really cores are not enough, cores are available, then it will take it. Okay.
Okay, okay.
Okay, any other questions, Tim? Are you able to see my screen? I am in the notebook. Are you able to see my screen?
Yes.
Okay, just a minute. Yeah, just give me a minute. Let me switch to some other network. No, no, no. Just I'm looking for notebook to load, as it is not loading. Just a minute. Let me try to re-upload again. Okay. Maybe let me switch to some other network. Hello. Hello.
Yeah, we can hear.
Yes, Mali.
Yes, yes, sir.
Yeah, sorry, it seems to be some other network issue. Disconnected from some other mobile also. Yeah, it is okay. Maybe we can discuss this lab tomorrow, team, because now I don't think we can complete it. So today we covered theory, right? Tomorrow we will do the hands-on. Even I am not sure why this is occurring. Is it due to the network or what it is? I need to see. Okay, so we will discuss tomorrow. Hands-on lab we will see tomorrow on the repartition versus Coalesce. We discuss theory today. Please focus on the theoretical things. Okay. Any questions if you would like to ask, you can ask me. I'll answer theoretically, but tomorrow we will see practical things. Any other questions anybody have? Hello. Anybody have any questions? Team, please confirm quickly.
No, no, no question.
Do you have any exercises that we could practice to, practice Spark?
Whatever we are discussing daily, please practice. That is more than enough. Okay.
Oh, okay.
First, you have to complete whatever we discuss. Later, if you still have time, you can let me know. I'll give you more assignments. Okay. Any other questions?
So sometimes partitioning, repartitioning, difference also they will ask, na? Sometimes, any interview.
Yes, definitely they will ask, not sometime. Very frequent interview question is the difference between repartition versus coalesce. Everybody will tell you it is used for increasing, it is used for decreasing. Everybody will answer, but you should understand how it is going to reduce, how it is going to increase repartition and coalesce in the back end. And if you have even distribution, how it can able to impact the performance when the source itself uneven distribution, how it will impact the performance and all. You should understand.
Okay.
So do we have the next ADF class?
What is your question?
Do we have the next ADF data factory class? Azure Data Factory.
Yes, yes, we have ADF class.
Okay.
Okay, then thank you all. Thank you.
Thank you.